It's funny, sometimes I stare at the moon and realise how little we actually understand about it. What's it really made of? How did it form? The easiest way to get answers would be to just go there, but NASA still isn't offering one-way tickets for people like me. So I decided to do the next best thing. Earlier this year, I visited NASA's most restricted scientific facility, the Lunar Sample Laboratory, the place where the world's most valuable moon rocks are stored and studied. Inside NASA's Apollo Sample Laboratory, as soon as you walk in, you realise this is the largest collection of moon material anywhere on Earth. There is literally no other spot on the planet where you can stand this close to so much of the moon at once. And yes, those rocks are worth around $12 billion. I wanted to know everything: how NASA brought them back, how they protect them, and what secrets they revealed about the moon's past. Back in the 60s and 70s, during the intense space race, humans knew surprisingly little about the moon. We had theories about its craters, we knew it lacked an atmosphere, but that was about it. Apollo missions changed everything. Bringing back untouched lunar soil and rock meant scientists could finally study the moon directly. But first, there was a huge fear. What if moon rocks carried alien microbes? NASA created strict planetary protection protocols. Both astronauts and rocks were quarantined, just in case anything harmful came back. They tested lunar soil on animals, mice, fish, even cockroaches. Luckily, nothing dangerous happened, and scientists were finally cleared to examine the samples. NASA learned quickly that working with moon rocks inside giant vacuum chambers was too difficult, so they shifted to nitrogen-filled glove boxes, a system still used today. These boxes keep samples perfectly dry and protected from Earth's moisture and air. From 1969 to 1972, 6 Apollo missions returned with 382 kilograms of moon material. And here's the amazing part: NASA has used less than 20% of it. Over 83% is still untouched, saved for future science. Most of it stays in Houston, with a secret backup vault stored at White Sands. Before Apollo, scientists could only guess why the moon has dark and bright regions. The dark areas, we assumed they were cooled lava, but the bright regions were a mystery. When the first samples came back, scientists were shocked. The white highland rocks were made of anorthosite, a type of mineral that floats on magma. This was the missing clue. It meant the moon wasn't always solid, it was once a giant ocean of molten rock. As it cooled, lighter minerals floated to the top and created a crust. Later impacts broke through and allowed dark lava to fill large basins. To confirm this, Apollo 15 astronauts were trained to find white rocks. They returned with the legendary Genesis rock, dated at 4.4 billion years old, just as ancient as Earth's early crust. One question remained: how do you melt an entire moon? The answer became the most widely accepted explanation today: the giant impact hypothesis. Billions of years ago, a Mars-sized planet named Theia collided with early Earth. The explosion launched molten material into orbit, which eventually cooled and formed the moon. Moon rocks are the evidence that made this theory possible. NASA scientists shared some great behind-the-scenes stories. For example, one famous rock called Seatbelt Rock only exists because an astronaut pretended his seatbelt broke just so he could stop and secretly grab an interesting rock. There were even reports of astronauts getting lunar hay fever from breathing moon dust, basically tiny shards like glass. Before I left, NASA allowed me into the most secure room of all. The vault, the door weighs 9 tons and is built to survive a Category 4 hurricane. Inside this clean, high-pressure environment, 70% of all Apollo moon rocks are stored in perfectly sealed, nitrogen-purged glove boxes. Every sample is triple contained in stainless steel tubes and Teflon bags. Nothing touches the rocks except stainless steel, aluminium or Teflon ever. NASA tracks over 128,000 individual samples created from the originals. What's next? Artemis and the lunar South Pole. NASA is going back to the moon soon with Artemis. This time, astronauts will explore the South Pole, an area with permanent shadows where frozen water ice has been preserved for billions of years. This ice may help answer huge questions. How did water reach Earth? Could it have delivered organic material? How much usable water exists on the moon? We've barely scratched the surface of what the moon can teach us. And over the next decade, with new missions and new samples, we might finally understand the full story of how our moon and our planet came to be.